This is lecture number 5 in the third week. So currently I am teaching the module number 1, which deals with mobile communication. So in the lecture 1, this is a summary so far what we have done. Introduction in lecture 1, frequency reuse concept in lecture 2, interference and system capacity in lecture 3 and 4. In my last lecture, I have worked out certain problems. So today I am going to cover, if possible, 2 topics: channel assignment strategies and improving capacity in cellular systems. So that's why I have given a different color. So remaining one will be handoff, that will be dealt in next lecture. So in continuation of this module 1, I know many of you haven't attended the last lecture, so I'm summarizing whatever I have taught in my last 2 lectures. So it was about interference and system capacity. Interference is the major limiting factor in performance of cellular radio system. So the service provider always search for a technique which can improve, which can increase their capacity or their subscriber base. They want to increase the number of subscribers, but one of the hindrance to this process is the interference, and this may cause one of the major concern today, that is call drop. 2 major types of system generated cellular interference are co-channel interference and adjacent channel interference. And apart from these 2, there is another important concept, that is power control for reducing interference. First of all, co-channel interference ratio is a function of the radius of cell R and the distance between the center of the nearest co-channel cells. These 2 parameters are very important. I have already defined in these 2 parameters in my last lecture. By increasing the ratio of D by R, the spatial separation between co-channel cells relative to the coverage distance of a cell is increased. Spatial separation will increase. So the very basic idea is, if 2 people are quarreling, you just separate out them, then the interference will be reduced. So the same thing is here. Physically increase the distance, the interference will be reduced. Adjacent channel interference resulting from the signals which are adjacent in frequencies. Say 2 carrier frequencies are very near, so desired signal is called adjacent channel. Adjacent channel interference results from imperfect receiver filter, which allows nearby frequencies to leak into passband. This adjacent channel interference is caused by improper design of band pass filter at your mobile, because your mobile is a receiver. Any receiver, the first block consists of a band pass filter. If it is not properly designed, it causes co-adjacent channel interference. And also the near far effect, in my last class I told you I'll discuss it. That means a person, your mobile phone is very much nearer to the base station antenna, then you will receive strong signal. If you move away from the base station antenna transmitter, you receive weak signal. So whenever the received signal is weak, this causes interference. So this is near far effect. This is an important effect for causing the interference. Adjacent channel interference can be minimized through careful filtering and channel assignments. The channels are assigned in such a way this is there is a technique of uh, channel assignment that I will discuss later on. By keeping the frequency separation between each channel in a given cell as large as possible. Say there are 1 to 10 channels in a cell. You use a group, not 1, 2, 3, 4, 5, 6, 7. You 1, 3, 7. Then between 1 and 3, this frequency separation is large as compared to 1 and 2. Have you got my point? The channel allocation scheme can also prevent secondary source of adjacent channel interference by avoiding the use of adjacent channels in neighboring cell sites. Okay. This you might observe. Suppose you are nearing to a transmitting antenna, that is base station. The base station controller will control the power transmission of your mobile. It will send certain control signal to your mobile, which in turn will control the power emission from your receiver. If you are nearer to the transmitter, the base station controller will send a control signal such that you will transmit less power because you are near. But if you move away from the antenna, then it will send a control signal such that it will transmit more power. Because you are far away, you need more power to transmit your signal. So this is power control strategy. Power control strategy is under the supervision of base station system. Now let's come to channel assignment strategies. In a cell, a set of channels are assigned. How they are assigned? What are the objectives? Increasing capacity, minimize interference. These two are objective of channel assignment strategies. Classification. Fixed channel strategies and dynamic channel assignment strategies. These two strategies or techniques are used for channel assignment. Now, what is fixed channel assignment? Each cell is allocated a predetermined set of channels. Any call attempt within the cell can only be served by the unused channels in that particular cell. Supposing there are 10 channels allocated to a particular cell. Out of these 10 cells, 7 cells are in use, and if anyone attempts to make a call, remaining 3, 10 minus 7, remaining 3, one of the remaining 3 will be allocated. If all the channels in the cells are occupied, then suppose 10 cells are there, simultaneously 10 calls are going on. If anyone makes an attempt to make a call, he will be blocked because no extra channel is there. This is fixed. You can't do anything. Okay. So what is the limitation? Limitation is it is not flexible. If the channels are available, anyone is making call will get a channel, otherwise it will be blocked. Now dynamic channel assignment. The channels are not allocated to different cells. There is a common pool. Each time a call request is made, the serving base station. So you are residing in a particular base station, you are sending a request for a channel. The base station in turn will send this request to the forward this request to MSC, mobile switching center. The mobile switching center then allocates a channel to the request cell following an algorithm. So how to allocate them? So a little bit of mathematics is there. So it depends upon logic. Depending upon logic, there are different kinds of strategies or algorithms are used. So what are those? The likelihood, that is probability of fixture blocking within the cell. So what is the a particular subscriber has got its own history, whether he hold a particular call for a longer period of time or shorter period of time. This history is there in mobile switching center. He will allocate depending upon his requirement or his past history, the frequency of use of the candidate channel, and the channel, how frequent it is used. So this is another factor. The reuse distance of the channel, how far this channel, this reuse distance, frequency reuse distance of the channel. So that is channel in co-channel cells. The other cost functions. So depending upon these parameters, dynamically it is used. So any particular cell is not allocated a fixed number of cells. It is allocated from a common pool depending upon the customer history, past history, and other factors. So this is about channel allocation strategy. Now, uh, you know, you must have experienced there is a sudden burst of requirement in any particular area for the increase in subscriber base of geo customer. In recently in any area there is a sudden surge of uh, increased customer base in a particular base station area or in a particular cell. Any particular cell has a particular capacity. It can serve, let's say, a few only allocated number of user. But if there is a sudden demand or if it is an increasing demand of customers, then how to handle, uh, how to solve this problem? So as the demand of wireless service increases, the number of channels assigned to the cell eventually becomes insufficient to support the required number of users. Technique to expand capacity of cellular system, there are two techniques. Number one is cell splitting. Increase the number of base station in order to increase capacity. This is cell splitting. One cell is divided into more than one number of cells. It depends upon, so how many division will be there depends upon the requirement or the demand. Sectoring. So relies on base station antenna. Normally one omnidirectional antenna is used. Omnidirectional means it radiates energy equally in all directions. This is a dipole antenna. A single antenna is there, which caters to the service of all the subscriber. Okay, these two red colors, these two are the important technique to improve the capacity. What is cell splitting? Cell splitting is the process of subdividing congested cell into smaller cells, each with its own base station and a corresponding reduction in antenna height and transmitting power. So these two factors are very important, height and power. Now you will ask why height is important? Because at this frequency the communication is known as line of sight. Line of sight, that means the antenna must see, so see your receiver or antenna and your receiver must be connected to a line. So as if you go to your rooftop, you can see many house around you because you have increased your position. You are now at a higher position. If you move on a road, you cannot see all those buildings. So in order to serve large number of customers, the height of antenna has to be increased and the transmitter power. So higher height and higher power requirement is there whenever you want to serve large number of customers using a single antenna. But if you divide it into more than one, what you do, you use more than one antenna and reduce the power of transmission, because one antenna will behave as a one cell. Cell splitting increases capacity of cellular system since it increases the number of times that channels are used. See, this is your original cell, and this cell is divided into three cells. This is bigger cell, smaller one. These smaller cells. These are called microcells. Okay, and thereby you are reducing the size or the diameter of the cell by half. If the older cell diameter is R, it will be R by 2. And this red color line indicates the channel cells. Okay. Now, if you repeat it over a large number of cells, say this cell is split into 1, 2, 3. Similarly, any neighboring cell, there is a regular structure. So again, 1, 2, 3, 4, 5 pentagon structure. The hexagon becomes pentagon to regularize the structure. Now this E, F, G, so all these are becoming independent cell. These are called pico cells. So this is showing a 3 kilometer by 3 kilometer square centered around a base station. So A is the base station. Around is, now you are splitting it. So within a area of 3 by 3 kilometers, see there are large number of base station is created. These are constituted out of picocells. Now, what is the benefit? Examining the receiver power, power reduced from old to new. So PR is the received power, is proportional to transmitted power R to the power minus N. N is the path loss exponent, how the power is reduced as you move away from the transmitting antenna. So received power is proportional to definitely transmitted power. Old cell boundary, and P at new cell boundary, PT2 R by 2, because R is half. Now if you take N, that is path loss exponent, as 4, set the received power, so PT2 will be PT1 by 4. It will be R by 2 whole to the power 4. If you substitute here, it will be 2 to the power 4, that is 16. So transmitted power in pico cell has been reduced from original power by 1 by 16th of its original power. The transmitted power must be reduced, that is 16 means in terms of dB to 12 dB. If one part of cell are splitted, define cell size, because if you want to split a cell, you need to have equal cells. Okay, so you can equally distribute, there is a symmetry, you can distribute the new customers within a new area, a new pico cells. So if another issue is, if you have different cell size, the handoff issue will come into effect. Sectoring, another technique to decrease co-channel interference, thereby increasing capacity by using directional antenna is called sectoring. Rather than splitting the cell, you can use directional antenna, because normally for cells omnidirectional antenna is used. So this is omnidirectional, means it radiates and receives signal in equal in all direction. So if you split in, if you use directional antenna called sectorial antenna, if you observe at the rooftop in, okay, the factor by which co-channel interference is reduced depends on the amount of sectoring used. Hello.
गुड आफ्टरनून सर।
गुड आफ्टरनून, कैसे हो?
सर कैसे हैं आप? हम ठीक है
मैं तो
सर।
जिंदा हूँ, बस सांसें चल रही है तो जिंदा हूँ, सांसें
बस बस
जैसे
बस
नहीं
बस
चलेगी
फुल है
बंद हो
सर।
जाएगा बस।
नहीं नहीं, अभी नहीं होगा सर। अभी
अभी नहीं ना?
लंबा चल रहा है
अभी
अभी।
तुम लोगों को पास कराने के बाद ही
हाँ, नहीं 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 सर, उसके बाद भी सर।
ठीक है। अच्छा अच्छा, तुम्हारा आजू बाजू में कहीं, अच्छा ये देखो, ये वाला देख लो और बात होगा इसके बारे में।
ठीक है
अच्छा, इस टाइप का एंटीना देखे हो अपना आजू बाजू में, सीधा फिगर?
सर। चार सर सर।
हाँ, देखे
चार
हो?
चार देखे सर।
है? अच्छा
अभी
देखो
नहीं है
ऐसे,
सर।
इधर
अभी नहीं
उधर
है
इधर
सर,
उधर
अभी
करके।
बड़ा वाला टावर है। अभी ये हट गया।
तुम्हारे अपने पास में है, नेबर में है?
हाँ, तो बड़ा वाला टावर है सर, लंबा वाला।
लंबा वाला नहीं, ये
हाँ।
देखो, ये वाला देखो, ये लेफ्ट राइट ऐसे करके है ना,
हम्म।
एक एक पर्टिकुलर एंगल में है। ये देखो, ये तुम्हारा सेल, सेल का एंटेना ये है, अभी एक था, अभी तीन हो गया। इधर एक ये वाला होगा, सेक्टर टू, देखो कहाँ दिया हुआ, सेक्टर टू एंड सेक्टर वन। ये देखो तीन तीन, पहले एक था, ओके, अभी देखो छह एंटेना हो गया। छह एंटेना किस लिए? एक एक सेक्टर में एक, मैंने एक सेल को तीन सेक्टर में, दो सेक्टर में डिवाइड कर दिया गया है। एक सेल था वन टू थ्री, तीन भी हो सकता है, छह भी हो सकता है। तो हमने छह अभी तक नहीं देखा, हमने तीन सेक्टर में देखा है। यहाँ पे छह होगा, और नाइन जब हो जाएगा, यहाँ पे नाइन मतलब है तीन सेक्टर में, तीनों सेक्टर में डिवाइड किया हुआ है। ये जो है ना, सी वन टू थ्री, वन टू थ्री, और ये साइड में जो है वो, उसमें भी वन टू थ्री होगा, इस साइड में भी वन टू थ्री होगा। सो नेबरिंग में ये देखो, तीन में क्या होगा, इसका सेक्टर वन एक, इसका सेक्टर वन एक, सेक्टर वन, इसका तीन होगा, वन वन नंबर, इसका दो दो नंबर का भी होगा, तीन तीन नंबर का भी होगा। जिस छत पे लगा हुआ होगा, तीन सेक्टर होगा, नो एंटेना रहेगा। Okay, so this is how it is splitted. More antenna means you must understand sectoring. Sectoring means next figure will show, this is 120. Each angle is 120. Total is 360. It is divided into three sectors. So 120 sectoring. Now, if it is divided by into six, each angle is 60 degree. 60 degree sectoring. It can be 120 or 60 degree, or it can be 180 also. Two sectors, 180, 180. See, this is radiating one sector, this is radiating another sector. These are the co-channel cells, same frequency I use. They are distance apart. So interfering cells, the distance is increased. And suppose this is your mobile, position of the mobile. Okay, and power of this transmitting antenna is reduced. So if you are residing it here, since the power is reduced, the interference is reduced and the distance is also reduced. This is how it works. So each cell can be divided into pico cell, that is this one. This can be further divided into pico cells. These are microcells, microcells and pico cells. This is the hierarchy. So pico, micro, macro, and all these are under satellite. This is the structure. So if you divide into sectors, these are known as 1A, 1B, 1C. Similarly, 2A, 2B, 2C. This is how it is divided. So increase in SI ratio. So Q is the frequency reuse ratio, D by R. D is the distance between co-channel cell. R is the radius of the cell. For omnidirectional antenna, Ni is the number of co-channels interfering cell. So Ni into Si for 120 degree, it will be Q to the power N. Q is this one for 120 degree. Divide by omnidirectional. So 120 by this, it will be 3. The increase in signal to noise ratio, it will be 3. 3 means root of 3, half. Almost it will be half. It will be doubled. Okay. So last one will be this one. Microcell. Oh, suppose this is your original cell. It is divided into microcell 1, 2, and 3. Each cell, they don't have transmitting antenna. These cells are connected through fiber optic or microwave link to a single station. So you need not require 3 antennas. Single antenna is sufficient, and so depending upon the service request, it will be sent to the single base station. So single base station will control which microcell will be activated. So zone concept, sites are connected to a single base station and share the same radio equipment. The zones are connected by coaxial cables, fiber optic cables, or microwave link. Multiple zones and a single base stations make up a call. A mobile travels within a cell. It is observed by zone with the strongest signal. This technique is particularly useful along highways or along urban traffic. So this is very important because you have only one antenna, but it is servicing 3 different regions. So whenever you are moving from one region to another region, you need not require any handoff. Handoff is a process. Whenever you are moving from one cell to another, your carrier frequency will be changed, your base station antenna will be changed. But if you are served by a single antenna, but you are moving over different places within a particular cell, you need not require any handoff process, because handoff is a costly process. It may cause a glitch or it may cause call drop. So if you want to avoid call drop or improve the performance or customer satisfaction, you need to go for this microcell. So this is all that in this. Let's come to the question. Okay. So this is about my presentation. So if you have any question, you don't have any question, then let me tell you who are present. Yogesh Kumar, Devangshu, and Anand Kumar, Saurabh Chakravarti, Athia Rana, Soumi, new entrant, Soumi Das, Motesam, Sheta Lal, Rahul Mondal. Oh, once Soumi has got attendance, she left. Okay, I note down this fact. Next time. Sheta Lal, Rahul Mondal, Debarun, Avrojit, then Anurag, Surajit, Ratan, Enamul Rahman, Satish Kumar. With this,
স্যার আমি আছি
হ্যাঁ দেবাংশু,
স্যার
হ্যাঁ
দেবাংশ
হ্যাঁ দেবাংশু দিয়েছি তো।
লাস্ট দুটো ক্লাসও ছিলাম।
আরে সেগুলো ঠিক করে দিয়েছি, দেখে নিস, আমি আপডেট করে দিয়েছি।
আচ্ছা আচ্ছা ঠিক আছে ঠিক আছে ঠিক আছে
হ্যাঁ
আচ্ছা আচ্ছা আচ্ছা
আমি কি আমার পকেটের ভেতরে রাখবো? তোরা এলে পাবি। আমি ডিস্টিংগুইশ করতে চাই কে আসছে কে আসছে না, পরে তারা নাম্বার কম পাবে বেশি পাবে, তোরাই তখন বলবি স্যার আমরা তাহলে টাইম নষ্ট করলাম, আমরা নাম্বার বেশি পেলাম না কেন, তোরাই তো বলবি কিরে, না সবাই একই নাম্বার পাবে? অ্যাসেসমেন্ট কিসের উপরে হবে? কে টাইম ইনভেস্ট করছে কে করছে না। ওকে ঠিক আছে, তাহলে বাকিদের একটু বলিস। আর মানডেতে আমার এই টাইমে তো ক্লাস হয়, লাস্ট উইকেও তাই নিয়েছি। ठीक है, ओके
सर लास्ट वीक का अटेंडेंस नहीं मिला था सर हमको।
अरे तुम आओगे तो मिलेगा। अनुराग तुम्हारा हो गया?
सर हम आए थे सर, हम इनामुल आए थे सर, हमको याद कर लीजिए आप।
अरे तो तुम आए थे तो मिलेगा, मेरे रिकॉर्ड में तो लिखा, जब तुम जब
नहीं,
एंट्री करते हो ना
आप दिए नहीं थे,
तब
हम
भी
मैसेज
तुम्हारा
भी किए
नाम
थे।
लिख लेते हैं।
आपको मैसेज भी किए थे लेकिन आप
हाँ
रिस्पॉन्स
ठीक है, देख लो, अभी अपडेट किए हैं आज।
अरे